Good day, everyone. I am Angelica Gutierrez, and today I am going to talk about the different classification of rocks. But first, let us answer the question, what is a rock? According to Abbott, a rock is a naturally occurring aggregate of minerals and certain non-mineral materials such as fossils and glass. Just as minerals are the building blocks of rocks, rocks in turn are the natural building blocks of the Earth's lithosphere, asthenosphere, mesosphere, and even part of the core. And now, let us discuss the outline of the different classification of rocks. According to Casablanca 2009, there are three major classifications of rocks, namely physical, chemical, and geological classification of rocks. Under the physical classification, we have three classes, namely stratified rocks, unstratified rocks, and foliated rocks. Meanwhile, under the chemical classification, we also have three classes, namely argillaceous, calcareous, and siliceous rocks. Lastly, under the geological classification, we have the three famous classes, namely igneous rocks, sedimentary rocks, and metamorphic rocks.
Number 1. Physical classification of rocks. According to ITBA 2018, this classification is also sometimes referred to as the structural classification of rocks, as it is based on the physical structure of the rock, or in other words, we classify the rock based on the physical structure that we can observe with our eyes. From structural composition of the rocks, there are three broad classes of rocks, namely stratified rocks, unstratified rocks, and foliated rocks. Stratified rocks. Stratified rocks are composed of layered structures that are connected as a result of stratification and possess plane of cleavage or cleavage planes or bedding planes. These layers and stratum can be easily detached from one another along that plane. The layers of the stratified rocks can be as thin as 1 cm and can be as thick as 1 meter or above. The color, size, and composition of the layers can be similar or different in nature. Unstratified rocks. As the name suggests, this class of rocks never show distinct layers in their structure beside having a compact, massive crystalline structure. That is why unstratified rocks are usually called as massive rocks, as they are intact in massive units. They cannot be separated easily in layers or slabs. Unstratified rocks are commonly found along with stratified rocks and are abundantly found in nature. The structure of the unstratified rocks are same along their depth and area. Foliated rocks. This classification of rocks is very common in case of metamorphic growth of rocks. Foliated rocks are formed in a layered structure that has been induced under lateral pressure. These rocks have a tendency of splitting along a plane of definite direction only, which is not necessarily be in parallel direction to each other, which was the case of stratified rocks. Chemical classification of rocks. According to Anna Podju, rocks are classified into three types based on their chemical composition, and they are as follows: argillaceous rocks, calcareous rocks, and siliceous rock. Argillaceous rocks. The word argil means clay. Hence, the rocks in which clay content is predominant are called argillaceous rocks. These rocks are soft in nature, and with the presence of water they can be crumbled easily. In the dry state, these rocks can be crushed easily because of their brittleness. Shale, slate, laterite, and etc. are some of the argillaceous rocks. Calcareous rocks. The rocks in which calcium carbonate is the major ingredient are known as calcareous rocks. These are generally hard, but their durability is dependent on surrounding constituents which may react with calcium and affect the durability of rock. Marble, limestone, and dolomite are some of the calcium-predominant rocks. Siliceous rocks. The rocks which contain silica in predominant amount are called as siliceous rocks. Presence of a large amount of free silica makes them harder and durable. It also provides strong resistance to weathering. Granite, chert, quartzite, etc. are examples of siliceous rock. Number 3. Geological classification of rocks. According to Casavolo 2009, among the different classifications, geological classification is the most proper one because the grouping of rocks is more logical, less ambiguous, orderly, and comprehensive. The geological classification of rocks is based upon their mode of origin. According to Casavolo 2009, Northstone Materials Division, and National Park Service 2019, rocks are classified into 3 types based on their geological formation, and they are igneous rocks, sedimentary rocks, and metamorphic rocks. Igneous rocks. From the Latin word ignum, which means fire, igneous rocks are the first formed rocks which had made up the primordial Earth's crust. For this reason, these are also called primary rocks even though igneous rocks have formed subsequently also. Igneous rocks are the most abundant rocks in the Earth's crust. In fact, their abundance is so much that the average composition closely tallies with the chemical composition of the Earth's crust itself. These rocks are formed at a very high temperature, directly as a solidification of magma or lava. Igneous rocks can be classified as extrusive and intrusive. Extrusive. Magma which reaches and flows onto the Earth's surface is called lava and is termed extrusive. Extrusive rocks tend to be very hot and fluid. The majority of lavas are of silica-poor basaltic composition. Present-day basalt lavas on Hawaii are molten between 1,100 to 1,200 degrees Celsius. If the lava has a high gas content, or if it is a thick viscous type of lava, the pressures involved can cause explosive activity which pulverizes rock and lava and violently ejects large clouds of ashes or ash and debris from the volcano as a result. The ash clouds settle to form layers of ash around the volcano. Intrusive. Magma which does not reach the surface but instead cools and solidifies within the crust instead is termed intrusive. Large-scale intrusions, which may be hundreds of square kilometers in extent, are called batholiths. Small-scale intrusions include dikes and sills, domes, stocks, and bosses. Intrusions are only revealed at the Earth's surface when erosion has stripped away the strata covering the top or roof of the intrusion. Magmas that form intrusions tend not to be as hot and are more viscous than extrusive basalt lavas. The majority of intrusive rocks are of silica-rich granitic composition, and placement temperatures are thought to be around 800 degrees Celsius. Sedimentary rocks. Sediments are the products of weathering. Since these are secondary materials, the rocks formed out of them are called sedimentary or secondary rocks. The origin of sedimentary rocks is totally related to the weathering influence on rocks. Sedimentary rocks can be classified as clastic, chemical, and biologic. Clastic. Clastic sedimentary rocks are made up of pieces or clasts of pre-existing rocks. Pieces of rock are loosened by weathering, then transported by erosion to some basin or depression where sediment is trapped. If the sediment is buried deeply, it becomes compacted and cemented, forming sedimentary rock. Clastic sedimentary rocks may have particles ranging in size from microscopic clay to huge boulders. Their names are based on their grain size. Chemical. Chemical sedimentary rocks are formed by chemical precipitation. This process begins when water traveling through rock dissolves some of the minerals, carrying them away from their source. Eventually, these minerals are redeposited when the water evaporates away or when the water becomes oversaturated. Biologic. Biologic sedimentary rocks form from once living organisms. They may form from accumulated carbon-rich plant material or from deposits of animal shells. Metamorphic rocks. These are the third major group of rocks occurring in nature. Their mode of origin differs from that of igneous or sedimentary rocks. They are formed from any pre-existing rocks under the influence of temperature, pressure, and chemically active solutions. The pre-existing rocks should naturally be either igneous or sedimentary rocks only. Even in such cases where some metamorphic rocks had served the role of pre-existing rocks, they too must have been formed earlier either from igneous rocks or sedimentary rocks. The metamorphic rocks formed from igneous rocks are called orthometamorphic rocks, and those formed from sedimentary rocks are called parametamorphic rocks. Metamorphism literally means change. In the geological sense, the term is used to denote the occurrence of textural, mineralogical, or chemical changes that have taken place in pre-existing rocks under the influence of temperature, pressure, and chemically active solutions. Metamorphism occurs in rocks because the two major groups of rocks, igneous and sedimentary, are formed under certain physical and chemical conditions. Metamorphic rocks can be classified as foliated and non-foliated. Foliated. Foliation forms when pressure squeezes the flat or elongate minerals within a rock so they become aligned. These rocks develop a platy or sheet-like structure that reflects the direction that pressure was applied. Non-foliated. Non-foliated metamorphic rocks do not have a platy or sheet-like structure. There are several ways that non-foliated rocks can be produced. Some rocks, such as limestone, are made of minerals that are not flat or elongate. No matter how much pressure you apply, the grains will not align. Another type of metamorphism, contact metamorphism, occurs when hot igneous rock intrudes into some pre-existing rock. The pre-existing rock is essentially baked by the heat, changing the mineral structure of the rock without addition of pressure. That ends our discussion about the different classification of rocks. And these are the works cited or the references used in this report or this video. That would be all. Thank you.